Okay, so this is Algebra 2, Chapter 10 review. First question is on number 12 on parabolas. Couple things to note about parabolas. Parabolas are in the form of y equals a to the x. This is if we have a upward facing parabola or a downward facing parabola, so a vertical parabola. If a is greater than 0, it faces up. If a is less than 0, it faces down. It has a focus, which is at 0C, where C is the focus, along the y-axis. This is where, for these all situations, the vertex is on the origin, and it has a directrix of y equals negative C. Okay. If it's a downward facing parabola, then it has a focus of negative C and a directrix of y equals C. Now, for parabolas that face to the right or face to the left, it's going to be x equals y squared, where the focus is at C0 and the directrix is at x equals negative C. And all those scenarios, a is equal to 1 over 4c. All right, so for number 12, we have a question where it asks us to write the equation given the focus. So our c is 5. So to answer this problem, we use the equation a equals 1 over 4c, where we replace c with 5, and we get a of 120. And since it's 5, 0, this is a rightward facing parabola, facing to the right, so we use x equals 120 y squared. Here we have a 0, negative 5, so we have a downward facing parabola. And we use the same equation, a equals 1 over 4c, but in this case we replace it with negative 5, and we have a equals negative 20th. And since it's a downward facing parabola, it's going to be y equals negative 120 x squared. For number 14, we have an upward facing parabola with a focus of 0, 6. We replace c with 6 and turns it to 1 over 24, and we have an equation of y equals 1 over 24 x squared. For number 15, they want us to write the equation of parabola given, and it's an upward facing parabola, at the origin with the focus that describes. So the coordinates for the focus would be 0, 2.5, and down here is 0, 1 over 12, where c equals 2.5, c equals 112. So same equation, a equals 1 over 4c. I'm replacing c with 2.5, and I get a equals 110. So my equation is y equals 110 x squared. For number 16, same exact thing. I replace c with 112. Multiply 4 times 112, I get 1/3. 1 over 1/3, which is a complex fraction. I multiply both top and bottom by 3, and I get a equals 3. And therefore, I get the equation y equals 3x squared. For number 17, they want us to write an equation of parabola given the focus and the directrix. So we have a focus, we have a directrix. The directrix is at negative 1, which means that c is 0, 1. Which gives me a c of 2, because 2 plus 3 plus negative 4 equals negative 1. So I have 2 k's, which is your y coordinate, and it's going to be our c is equal to 2. So we put 2 in for 4 and have 1 over 8x squared plus 1. And the plus 1 is coming because we moved it 1, 2, up. 1 up. Okay. 18, same thing. Where's 18? Here, instead of it being C, K is going to be H. So you have H plus C equals -2, and H minus C equals 4. Where this -2 is the focus and this is the directrix. So what we're doing is we're having two equations. The H plus C is from the vertex to the right, and this is from the vertex to the left. And the reason why we have -2 here is because the focus is -2. The reason why we have 4 here is because the directrix is 4. So it's going to be H minus C because that gives us the directrix. Is going to be H plus C because that's our focus. We cancel out the C's, and we get that H is equal to 1, which is our plus 1. And we get our C is equal to -3 when we plug it in. So we plug in -C here, and we get -112. So our equation is x equals -112 y squared plus 1. All right, number 19, I want you to find the focus and the directrix and sketch the graph. So our A is 5, so we set 5 equal to 1/4C. That gives us that C is 1/20th, so that's our focus. Since it says y equals x squared, that's an upward facing parabola. Our directrix is going to be -1/20th. For number 20, this is a rightward facing parabola because it's x equals 2y squared. We set a equals to 2, and 2 is equal to 1/4c, multiplied by c divided by 2, and we get that c is equal to 1/8. So our focus is going to be 180, and then our directrix will be -1/8. X equals -1/8. X equals -1/8y squared. That is a leftward facing parabola. Where -1/8 is equal to 1/4c, we get c equals -2, which means that our directrix is going to be at x equals 2. Okay. So that's parabolas. Next we will do circles, if I'm not mistaken. No, I'm not trying to print. All right, circles. So circles are in the form of the equation x minus h squared plus y minus k squared equals r squared, where r is the radius, h is the distance from x, the horizontal distance from x, and y, k is the vertical distance from y at the center. So for number 22, they give us a center of 0 and a radius of 4. So x minus 0 squared is x squared, y minus 0 squared is y squared, and then 4 squared is 16. So our equation is x squared plus y squared equals 16 squared. 16. For number 23, we have 8 and 1 and a radius of 5. So x minus 8 squared, right, because that's 8. Y minus 1 squared, and 5 squared is 25. For number 24, they say it moves up or to the left 3 units, and it moves up 2 units. So if it's moving to the left 3 units, that's going to be x plus 3, or x minus -3, which is x plus 3 squared, plus y minus 2 squared, and then equals 100 because that is 10 squared. For 25, it says it's right 5 units and down 3 units, so that's going to be x minus 5 squared plus y plus 3 squared, or y minus -3 squared equals 8 squared, which is 64. And they want us to sketch a circle from the origin. So here's our origin. It's moving to the right by 1, so there's my center at 0, 1. And it has a radius squared of 64, which means that the radius is 8, so I go 8 to the left, 8 up, 8 to the left, 8 to the right, 8 down, and make my circle. For 27, it says it's 7 units to the left and 3 units down, and The square root of 49 is 7, so 7 to the right, 7 up, 7 to the left, 7 down. Okay. Then here it says 1 unit to the right, 7 units to the left, 3 units down. Circles. Ellipses. Elongated circles with 2 center of mass. Ellipses have 2 focuses called 2 foci. It occurs along the major axis, which is the axis that contains the 2 foci, and it's endpoints of the ellipse, and then they're called the vertices. If A is greater than 0, or B rather, if A is greater than B, then our equation is going to be x over A squared plus y over B squared equals 1 along the major axes. Now this would be a horizontal ellipse. The vertices would be plus or minus A0, the foci would be plus or minus C0, and then we have something called co-vertices, which are perpendicular to the vertices along, usually in this case, the origin or the y-axis, and that's going to be 0 plus or minus B. Now B, if we have a vertical ellipse, the equation changes a little bit, and we're going to have x squared over b squared plus a squared, y squared over a squared, x squared over b squared plus y squared over a squared. That's going to equal 1. The major vertical axes are going to be 0 plus or minus a, the foci 0 plus or minus c, and the covertices in this case is going to be plus or minus b0, so everything switches. And to find the focus, it's going to be c squared equals a squared minus b squared. So for the first one, 28, they want the equation given the foci and the covertices. So we have C and we have B, but we need A. So we're going to use the equation C squared equals A squared minus B squared. Add 16 to both sides and then square root. So A is going to be a square root of 17, or A squared is 17. So when we write the equation, it's going to be A squared over x squared over 17 plus y squared over 16 equals 1. For 29, we have a vertex of square root of 29, so that's our A, and we have a covertex of negative 5, so negative 5 squared would be 25. So we have our vertex, and we have our covertex. So our vertex is 29, our covertex is 5. Since the vertex is at 0 square root of 29, that tells me that it's going to be a vertical parabola. So the 29 goes under the y squared. So it's going to be x squared over 25 plus y squared over 29 equals 1. For number 30, we have a focus at 0, 1 and a vertex at 0, 10. Again, this is going to be another vertical ellipse. We use the equation c squared equals a squared minus b squared. So 1 equals 10 minus b squared. So b squared is going to be equal to 9. So our equation is going to be x squared over 9 plus y squared over 10 equals 1. For 31, we have a foci of plus or minus 2 and a covertices of plus or minus 6. So we have to tell me that's a horizontal ellipse. And we're going to use the equation c squared minus a squared equals b squared. And that's going to give us 4 equals a squared minus 36. So a squared equals 40. So that's going to be x squared over 40 plus y squared over 36. And that's going to equal to 1. Write an equation of an ellipse centered at the origin with a height of 8 and a width of 16. So since our width is 16 and we're dealing with a horizontal parabola because it's wider, we divide it by 2 because it's going to be the distance from vertex to vertex. So our A is going to be, that's going to be our distance A from the origin to the vertex. So that's going to be 16 divided by 2, which gives me A. I squared 8, and I squared 8, and I get 64. Same thing with B. From vertex to vertex, it's 8. So I'm going to divide that by 2, which gives me 4, and then square it because it's 16, because the distance from the length of the vertex cuts down the middle, and the distance of the height from the ellipse, rather, cuts down the middle. So our A squared is 16, our B squared is, A squared is 64, and our B squared is 16. So it's going to be x squared over 64 plus y squared over 16 equals 1. They want us to graph this. This is a vertical parabola because the 9 is bigger than 4. We square root that and we get an A of 3. So from 0 to the top is going to be 3. 0 to the bottom is going to be 3. So 3 up, 3 down. We square root the 4, and that's our B, our covertices, and it's going to go over 2, and then we have our ellipse. And our foci is 0 plus or minus square root of 5, which is like around here somewhere, or here, around 2 something here, and 2 something here. So that is the ellipse. Next we have the hyperbolas. Alright, so hyperbolas, similar equation to ellipse, but a little different. We have two foci. We have something called the transverse axes, which is this guy right here, where the vertex and the foci both lie on. There's two standard equations of it. We have x squared over a squared minus y squared over b squared equals 1. We have asymptotes, which are slopes. In this case, it's going to be b over a when it's a horizontal ellipse, and our vertices is going to be plus or minus a, and then our foci is going to be plus or minus c0. For horizontal, vertical hyperbolus, it's going to switch, and it's going to be y squared over a squared. See the difference? Minus x squared over b squared equals 1, with asymptotes a over b plus or minus these slopes. With a vertical axis, vertices of 0 plus or minus a, and a foci is 0 plus or minus c. And c squared equals a squared plus b squared. So some minor differences between the two equations. All right, so for 34, they want you to find the foci and graph the hyperbola. So we have our a squared and our b squared. A squared is 36, b squared is 225. So to get it, it's going to be a squared plus b squared. And to get c, I'm going to square root that. So 225 plus 36 is 261. So c is equal to plus or minus 3 square root of 29. So our foci is 3 plus or minus 3 square root of 29, 0. Our vertices is plus or minus 6, because it's square root of 36. So here's that square root of 36 here. 2, 4, 6. Yeah, I'm going to go to. Here's 6 here, so those are vertices. Our slope is going to be b over a. So b is 25, so it's going to be 15 over 6. So I go up 15. Go up 15 and go to the right 6, and that's my slope. I go down 15 and to the right 6, and that's my downward slope. So these are my asymptotes. And since I know they're horizontal, I know they're going to go along the asymptotes. For 35, we have y squared over 400 minus x squared over 169 equals 1. So that's going to be 400 plus 169 square root, which gives me 569, square root of 569. So the foci is going to be 0 plus or minus 569 because the y is first on top. So this is a vertical hyperbola. With the a of 20 and a b of 13, so my vertex is going to be on 20, here and here. The slope is going to be b over a, so 13 over 20, so 13 over 20 right here. Goes in that direction, that direction. 36 x squared over 121 minus y squared over 81. Again, c is equal to 121 plus 81 square root, which gives us square root of 202. So our foci is square root of 202 is 0. So we're dealing with a horizontal. Our slope is b over a. So that's going to be 9 over 11. So coming from the origin, 9 over 11, and that's my first one. 9 over 11, that's my second asymptote. The vertex is at 11, 11, so I'll go over here to 11, 11, and then create my graph. Okay. So number 37, they want the equation given the situation. So we have foci at plus or minus 17 and vertex at 8. So that's my A is 8 and my C is 17. So 17 squared equals 8 squared plus b squared. So I'm going to subtract 8 squared from both sides, and I get that b squared is 225. So my equation is going to be x squared over 64 minus y squared over 225. And I know that it's x squared first because my foci is 17, 0, which is along the x-axis, which tells me I'm dealing with a horizontal hyperbola. Okay, so 38. This is different, so I'm going to have y squared first because it's a vertical. My foci is at plus or minus 25, and my vertex is at plus or minus 7. So 25 squared plus 7 squared equals b squared. Subtract 7 squared from both sides, and I get b squared equals 576. So it's going to be y squared over 49 minus x squared over 576, and that's going to equal 1. All right, it says 39, find the equation that models the hyperbolic path of the spacecraft with a of that and c of that. So big numbers. We have an a, we have a c, we have to find a b. So a squared is 107, 124, b squared is 213, 125.9. I square them, I subtract it from both sides, and I get that b squared is 3.395 times 10 to the 10th power. All right, and the square of 107, 124 is 1.148 times 10 to the 10th power. So my equation is going to be x, and it's because, let's see, x squared over 1.148 times 10 to the 10 minus y squared over 3.395 times 10 to the 1. Okay, that is this review. Oh shoot! I hope you have a great rest of your day.